So let's take a look at example 2 here, where we're solving 3 times the absolute value of 2x plus 4, that quantity, minus 1 less than or equal to 8. Before we can do our 2 options, we must isolate that absolute value. So let's add 1 to both sides. And that will give us 3 times the absolute value of 2x plus 4 is less than or equal to 9. Then let's divide both sides by 3. And so we get 2x plus 4, that quantity is in absolute values, less than or equal to 3. Now we can do our 2 options. Option 1 is the inside is the positive version. So we get a positive 1 times 2x plus 4 is less than or equal to 3. So 2x plus 4 less than or equal to 3. Subtract 4 from both sides. We get 2x is less than or equal to negative 1. And then divide both sides by 2. We get x is less than or equal to a negative 1/2. Now we do the second version. Our second possibility is the inside is the negative version. So we're going to distribute a negative 1. Negative 1 times the quantity of 2x plus 4 less than or equal to 3. Distribute, and we get a negative 2x minus 4 less than or equal to 3. Add 4 to both sides. We get negative 2x less than or equal to 7. Now when we divide by the negative 2, our inequality is going to change. And so we get x is greater than or equal to a negative 7/2, which if we're going to graph that, that gives us a negative 3.5, kind of gives us an idea of where it is. And now we can graph the solutions on the number line so we can determine where our interval or intervals lie. So our first one was that x is less than a negative 1/2. So here is a negative 1/2 less than or equals to, moves it to the left here. Our second possibility gave us x is greater than or equal to a negative 3.5 or a negative 7/2, which is here. But that is greater than or equal to, so it shifts to the right. You might look at it and go, oh, well, it's all real numbers because we're going to end up graphing everything. But let's take a look at our original equation here, where we're looking for the values of x that will give us a distance smaller than 8. Or if you want to look after we get the absolute value by itself, we're looking for a value of x that would give us a distance smaller than 3. So you're actually looking for an interval around certain numbers. So in this case, we look to see where these 2 intervals overlap. And they overlap here between the negative 3.5 and negative 1/2. So you can leave it as negative 3.5 if you want to, but recall that we have a less than or equals to. So that means we're going to use brackets to show that our endpoints are included. Negative 3.5 all the way to a negative 1/2, both endpoints are included. All right, so the next couple of examples here are kind of unique. Notice the example here on the left. We want to solve an absolute value that is less than negative 1/2. What this is saying is the distance from a negative 8, because we don't have the subtraction, is less than negative 2. So here's our thought here. We cannot have a negative distance. So this guy here is no solution. There is no x that if I took the absolute value, I would end up with a number less than a -2. But notice in this problem, the absolute value is already isolated. So let's say if I had a -2 absolute value of x plus 3 less than a -1, we cannot make that decision here because I haven't isolated that absolute value. Once I divide by -2, I get greater than a +2. That's doable. So we can't make the no solution decision until after we've isolated the absolute value. The next problem here to the right, we're asked to solve the absolute value where it's greater than -3. So again, this is saying the distance from a -4 is larger than a -3. Well, all distances, right, are larger than -3. Than any negative, actually, than a negative. Because remember, your absolute value would always give you a positive number. Positives are always larger than negatives. So any value of x from -infinity to infinity would work, okay, for all real solutions, or all real numbers, I'm sorry.